So today we're going to talk about shifting conics. So I'm going to give you a bunch of new formulas. So you need a new formula sheet or add to your existing formula sheet. These are the same equations, but with the ability to shift a graph right or left, or up or down, or both. Other than that, well, everything's pretty much the same. So if you try to graph this equation, right away you notice, hopefully you notice, that this is a minus sign. What does that mean? If there's a minus sign right there, hopefully you know that means it's going to be a hyperbola. So an ellipse would have a plus sign in between the x squared and y squared. And so when it's a hyperbola, you're not looking at the a value down at the bottom, you're looking at which one is first. Because y is first, this is going to be a vertical hyperbola. So I'm going to give you the formulas for a vertical hyperbola. So these are the new formulas for a vertical hyperbola. It's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. It's very similar to the old formula, but now we have y minus k and we have x minus h. Before we just had y squareds and x squareds. And so let's find the vertex. So the vertex is literally h comma k, right? That's the formula for the vertex for a parabola. So we can just identify h and k. Now what's weird is the h is attached to the x here, right? The h is x minus h. So the x minus 3, x minus h. So h is actually a positive 3. Notice that it says minus 3, but the h is actually positive there. Same thing happens here for y. So the formula is y minus k. This is y minus 1. So k must equal positive 1. Even though it says minus 1 there, it's a positive 1. So 3, 1 is my vertex, or my, I guess that'd be my center. I should say my center of this vertical hyperbola. Okay, so let's figure out what's next. So let me give you the other formulas here. So the focus, well, let's do this just like we would normally do it. First, I'll give you the formulas. So underneath y is vertical movement, so I know it's going up or down. This is equal to my a squared for a hyperbola according to the formula, so a is equal to 5. So I'm going to go up 5, not from the origin, but from the center there. So 1, 2, 3, 4, 5. Go down 5, 1, 2, 3, 4, 5. So we have a new starting point there. So you can see those 2 points. X is always horizontal, so I'm moving horizontally here. So the b squared value is equal to 49, which means b equals 7. Instead of starting the origin, I'm starting at the center. Go to the right 7, 1, 2, 3, 4, 5, 6, 7. To the left 7, 1, 2, 3, 4, 5, 6, 7. Okay, so the next step in graphing is our dot box, right? You go like this, fill out the corners of the dot box, go ahead and draw the dotted diagonals there. And this is vertical. We said it's vertical, so I know this is the vertex right there, and that's the vertex right there. And at that point, you would just draw, that stays within the parameters. I'm a little bit off the screen here. I don't know if you can see it, but it kind of goes down that way. Okay, so I've graphed it. So we want to find the coordinates. There's a couple of formulas I definitely want you to have written in your notes for a vertical hyperbola. So one is going to be for the focus points. So the focus points are going to be, we're going to start with HK. We're going to move up or down from those. So it's going to be H, comma, K, plus or minus C will be the focus points. The vertex points, I'm just going to use V for that, would be H, comma, K, plus or minus A. So we're going up and down A units. So just to show you how this works, let's plug in something we already know. We know the vertex is there and there, right? So let's plug in the points. So H should be 3. K is 1, plus or minus A was, I believe A was 5. So see, that would be 3, comma 6. Let's see, 3, comma 6 is right there. That's one of my vertex points. 1 minus 5 is negative 4, so 3, comma negative 4, which is my other vertex point. So it hits those exactly. if we do this formula, that would be h would be 3, k is 1 plus or minus c. We have to figure out c. So c squared equals a squared plus b squared. So that would be 25 plus 49 here. So c squared equals 60, 74. So the square root of 74, whatever that is my c value there. So square root of 74 is a little less than 8. So I'm going to go 7 point something. 1, 2, 3, 4, 5, 6, 7. A little less than that. So somewhere right up there, and go down there as well, make my focus points. I just ran out of room on the graph. So those are the formulas you need for vertical hyperbolas. Let's go ahead and write down the formulas for horizontal hyperbolas as well. So for horizontal hyperbolas, you'll need these. So these are ones that are going kind of off to the side here. So it's going to be the x term is first, so x minus h squared over a squared minus y minus k squared over b squared equals 1. So a squared is always on the left for hyperbolas, but because my x is first, it's definitely horizontal. So then the focus points, if you need the formulas for your notes, which you want these, h plus or minus c comma k, and the vertex formula would be h plus or minus a comma k. So it's kind of similar to some of the others. And so those are the formulas you need for your notes. Let's try an ellipse here. Okay, so this right away, okay, this is, looks to be, so for, you have to adjust back, you got to change modes. Okay, this is an ellipse, so a squared, so the x doesn't determine it's horizontal, this does. This is equal to a squared here. So a squared is 64, the bigger number is that one, so a is 8. The b squared value is 36, so b is equal to 6. So I know my a and b, which is nice. The starting point, it's really helpful to find your vertex, right? So your center, I guess for this type of figure, it's called the center. So it's x minus h, so it's going to be at h comma k. So hk is going to be x. So what the formula, let's look at the formula. So the formula is x minus h squared over a squared, this is for horizontal, plus y minus k quantity squared over b squared equals 1. So if you see the 3 there in the h, so x minus 3, the h value is 3, the k value is 3, so we get the point 3, 3. So that's my center of my ellipse here. So really we graph it the same way we've done before. So underneath x is horizontal movement. So I don't go 64 to the right and left, I go 8 to the right and 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. I'm a little off the screen there. 1, 2, 3, 4, 5, 6, 7, 8. That's better there. Y is vertical movement. So underneath y is 36. So I go 6 units up. 1, 2, 3, 4, 5, 6. And 6 units down, 1, 2, 3, 4, 5, 6. This is an ellipse, so I can go ahead and really graph it at this point. Whoops, it's not the greatest, but that's the idea of it. Comes down a little better there. Okay, the formulas you need for this. By the way, this guy, I always like to kind of at least think in my mind, what's the major axis? This is definitely horizontal. The a value, 8 is bigger than 6 there. So you might think about, okay, what's the focus point formulas going to be? So the focus point formulas would be h plus or minus c comma k. We can use that in a second. And then the vertex point formulas, if you need them, would be h plus or minus a comma k. So if I plug in order pairs here and stuff, the focus point would be 3 plus or minus c. I don't know, but I could figure it out, right? For this to be c squared equals a squared minus b squared. So I think c squared equals 28. So c equals square root of 28, which is, I think, 2 root 7. Plus or minus 2 root 7, comma k, which is 3. And then this one would be, so that would be 3 plus or minus a is 8, comma k is 3. So 3 plus 8 is 11. That's that point way on the right. This one's the other vertex. It's 3 minus 8 is negative 5, which that's negative 5, comma 3. And so I've got those points. 2 square root of 7 is approximately 5 point something. So 3 plus 5 is 8 point something. 1, 2, 3, 4, 5, 6, 7. A little off the screen there. 1, 2, 3, 4, 5, 6, 7, 8 point something. Pretty close. This is pretty squished, so it's pretty close to the end there. But those are the formulas you need for the, I should write this as the, these are all for the horizontal ellipse. Let's go ahead and write the formulas for, let's write the formulas for vertical ellipse. So for vertical ellipse, we've got, it's going to be x minus h squared plus y minus k squared, quantity squared, equals 1. Big difference is the a squared value is down there and the b squared value is down there. The focus for a vertical ellipse would be h comma k plus or minus c, and the vertex would be h comma k plus or minus a. So just go ahead and write those down. Let's let's get rid of this. Let me try one here. So I'm going to make one up. So let's see. It's going to be, let's do this one. So x equals negative 1/8 times y minus 3 squared plus 2. So hopefully you can see right away that is definitely a horizontal parabola, right? Only one of the terms is squared. That's definitely a parabola. It's kind of solved for x already, which is nice. It's kind of a parabola that either opens up to the right or to the left. It's kind of one of those kinds of parabolas. In fact, it really opens up. This one opens up to the left, right? You can kind of tell because the a value is negative. So definitely opening left, which could help. But let's find our hk. So we need to know our formula. X equals a times y minus k squared plus h. So our h, so we want that vertex, which is h comma k, right? So our vertex is going to be, h is actually positive 2 there, and k is positive 3. So 2 comma 3 is our vertex. That's our vertex. It's helpful to figure out c. It really always is. So c equals 1 over 4 times a. A is negative 1/8 there. So you get 1 over negative 1/2, which is negative 2. So I get c is negative 2. If it's me, I'm probably just drawing this at this point. So I'm going, okay, to the left because it's negative. That's my focus. To the right would be my directrix. So x equals, it looks like there'll be 4 would be that. I'm going to go, I went to the left, that's c, so I'm going to go 4, twice that amount down, 4 down, and 1, 2, 3, 4 up. And you can graph your graph. And so we get, so let's write down the formulas for the other things you need here. So you need 2 more formulas with this. So, because we could have used the formulas to graph those. I didn't need them, but you might. So h plus c comma k is our focus for horizontal. This is for horizontals. The directrix line equation, the new equation, this is for shifted conics, would be x equals h minus c. So those are the equations you need for horizontal parabolas. Let's see if this works. So let's just try it, right? So if I'd use the formulas, let's see if they work. So this would be h, which is 2, plus c, which is negative 2. Whoops. So let's write that again. So h, which is 2, plus c, which is negative 2, comma k is 3. So I should have a point at 0, 3, because that is 0, 3, right? Because that's 0, 3. So that's my focus point. So it does work. Good. Formula for this would be x equals h, which is 3, minus c, which is negative 2. 3 minus negative 2 is like 1, 2, 3. Let's see. Oh, h is 2, not 3. 2 minus negative 2, which is 4. Okay, and this is x equals 4. It does work. Yeah, if I plug in the right numbers, it definitely works. Okay, let's write down the formulas for vertical parabolas. So vertical, it's the only thing we don't have yet, vertical parabolas. Okay, so you've seen this formula before. A times x minus h squared plus k. Let's see, our focus formula will be h comma k plus c. Our directrix will be y equals k minus c. So that's a k there, k minus c. So for our directrix. So that's the big difference with today. You definitely need to do your homework. It's super important you do your homework today to practice this, because about half your test is going to be shifted conics. You need to, the same concepts apply. It's not that bad if you have all the formulas, because you have the formulas to rely on. And again, the concepts are exactly the same. It's just your center has been changed. It's no longer going to be, 0, 0. So that's the big change in today's lesson. I'm going to stop it and definitely go do your homework. Did I say do your homework? Do your homework.